Hello. Welcome, grade 12s. I will be doing this cubic function question. Let us start with it right away. We've got question 1.1, which requires us to solve for x. So you solve for x if f of x is equals to 0. So what you are going to do is that you are going to write your function, or they made a mistake, they wrote h of x and then it's f of x. So let's say it's h of x there. So solve for x when if h of x is equals to 0. Then under h of x you write your function, which is 2x cubed minus 5x squared minus 4x plus 3 is equals to 0. But now, how are we going to get the factors of this cubic function? So we are going to use a calculator to find at least one factor. Then we take it from there. So what you are going to do is that you are going to press in your calculator the mode set up. The mode. Then we have different calculators, guys. So in my calculator, it's for table, it's number 7. So you press table. Then it will just give you a function of f of x. Then you punch your f of x by pressing 2. You press 2, then alpha x cubed, and minus 5 alpha x squared. Sorry. 5 alpha x squared. And then minus 4 alpha x, and then also plus 3. Then when you are done inserting your f of x, g of x, you do not have g of x, you press is equals to start. You start, this is your domain, you start from -3. You just choose maybe -2 to 2 or -3 to 3, just like that. So I'm going to start with -3 up until 3. Then step, you press 1. Then tada, that is your table. Now in your table, you're going to have at least one factor which is equals to 0. So I see x is equals to -1, the first one. Yeah, when x is equals to -1, my f of x is equals to 0. So I'm going to use that one. But here, when I write it, I write x plus 1, not x minus 1. Please be careful of that. X plus 1. Then I'm going to do what? I'm going to, in my other bracket, I'm going to have ax squared plus bx plus c is equals to 0. You can use a synthetic division to find the other factors. It depends on you. So I'm going to use this method whereby I multiply the first term by the first term to get the first term. So I already have my a. It's going to be x times ax squared is equals to 2x cubed. Then x times that is going to be ax cubed is equals to 2x cubed. Because of it's an x cubed and x cubed, therefore my a will be 2. It's okay. They already got an a. It's fine. We're going to just write it there, or a. Then for b, let me just start with c. For c, I'm going to take the last term by the last term to get the last term. Then it's going to be what? It's going to be 1 times c is equals to 3. Therefore, c is equals to 3. I'm done. Then to get my b, I'm going to do like this. This one and this one, a smiley face. The x and the bx and also that one is equals to the one with a squared. So be careful of that. So it's going to be what? It's going to be what x times ax squared, times bx plus 1 times ax squared is equals to negative 5x squared. Then it's going to be bx squared plus ax squared is equals to negative 5x squared. Then I just ignore the x squared. Then I have an a which is 2, I have an a which is 2. B plus 2 is equals to negative 5. Therefore, b is equals to negative 5. And then you just apply additive inverse. Then it's going to be negative 7. Then your factors will be x, the first one, x plus 1. Then 2x squared minus 7x plus 3 is equals to 0. That is your factorization. This is how I factorize, but we can use synthetic division if we want to. Then we just factorize this x plus 1. We're gonna have 2x and x. And then 2x and x will factors of 3. You can say we have our signs will be both minus because of a negative, and a negative is positive. And then I think 1 and 3, yeah, it will give you that. Therefore, x is equals to negative 1. That is the one that we got when we punched in a calculator. Or 2x is equals to 1, or x is equals to 3. We are not done here. We're going to say x is equals to half. Those are your 3 x values. Then the second question, calculate the coordinates of the turning point. So guys, for turning point, you are going to differentiate your function. So you have h of x is equals to 2x cubed, minus 5x squared minus 4x minus 5x squared minus 4x plus 3. So you're going to differentiate the function for you to get the maximum and the minimum, which is the turning point. So it's going to be the first derivative. Always for the turning point, TP of a cubic function, it is the first derivative. So it's going to be 2 times 3. We're multiplying the exponent and this. 2 times 3 is 6. Then you subtract the exponent by 1, which is 2. Then negative 5 times 2 is going to be negative 10x. Then for that one, the answer is just negative 4. It's negative 4. Why is it negative 4? Why is it just negative 4? Let's say it was like this. There's a 1 there. So it's going to be negative 4 times 1, x, 1 minus 1, which is negative 4x. 1 minus 1 is 0. Then any number to exponent of 0 is 1. It's going to be negative 4 times 1, which is negative 4. I hope it is clear. Then the derivative of a constant is 0. So you don't have to write anything there. It's 0. Then you equate to 0. Then here you factorize. I'm going to take a common factor, which is 2. Then I'm going to remain with 3x squared minus 5x minus 2. Then the 2 will just go off. I'm going to have 3x squared minus 5x minus 2 is equals to 0. Then I factorize 3x and x. Then I'm going to have minus 2 plus 1. 3x squared minus 6. Yes, that's correct. Then 3x is equals to negative 1, or x is equals to 2. Therefore, x is equals to negative 1 over 3. That is your x value. Those are the x values for the turning point. You have to find the y values. How do you find the y values? You substitute these two x values into the original equation. Please be careful of that. So it's going to be h of negative 1 over 3. You just punch in your calculator. You don't have to write the formula. You just press, the formula is 2 into negative 1 over 3 cubed, minus 5 into negative 1 over 3 squared, minus 4 into negative 1 over 3 plus 3. You are getting 100 over 27. Then you find h of 2. You just delete in your calculator. You don't have to waste time, guys. You just delete in your calculator. You write 2, you press 2, you delete 2, you delete and punch in 2. Then you get negative 9. So the turning point, the coordinates of the first turning point, which is this one is the minimum because of the negative, is smaller than that one. Is the minimum, which is negative 1 over 3 is 200 over 27. And then the other turning point is 2 is to negative 9. No, the minimum is this one. I'm sorry about that. The minimum is this one. I'm checking the y value is smaller than that one. So this one is the minimum. This one is the maximum turning point. I hope it is clear. And then next question. Draw the graph of h. So for you to draw the graph, you need your Cartesian plane. This is your x, this is your y. You start with the x-intercepts. You've got negative 1, half, and 3. So negative 1, this is 1, 2, 3, just like that. 1, 2. I have 100 over 27 also in my thing, so it's 3. Okay. Then I'm gonna have negative 1, negative 2. I have negative 9. You just have to estimate. Then you start by plotting your x is 1. 1 over 2 is between 0 and 1, and then also 3. We forgot one thing, the y-intercept. The y-intercept, how do you get the y-intercept? You let x be 0. So your y-intercept of this function is always the d value. This one is your y-intercept. So it's 3. It's 3. Then you are just going to go straight to 3. Then your turning point now, negative 1 over 3. The first one is negative 1 over 3. It's somewhere here, negative 1 over 3. Which is negative 0.33. This is negative 0.33, which is somewhere here, and then that one it's a 3.7. 100 over 27 is 3.7. So it's somewhere there. That is your turning point. Another one, 2. Let me just use a different color for turning points. And then 2 is to negative 9. Another point there for turning point. Then you connect your function. I'm not sure. Turning point, y-intercept. I don't know how to draw, but it's no. It must look like it's gonna turn somewhere there. My graph is not nice, guys, but this is the idea of how you're going to draw your graph. It must have a turning point, the maximum and the minimum. Maxima. It's the maxima and the minima. Sorry, the maxima and the minima. And then it must also have the x-intercepts. Then the point, the midpoint between the two, the maximum, the minima, is known as the point of inflection. That is the second derivative. So let's continue. For which values of x will the graph be concave up? Concave up, when they mention concave up, that is the second derivative. So let's look at this idea. Concave up. your second derivative, h of x or whatever, must be bigger than 0. Then concave down, the second derivative must be less than 0. So they want the values of x for which the function will be concave up. So we are going to say we are going to look for h prime x. So you continue from the first derivative, which was 6x squared minus 10x minus 4. It was h of x was 6x squared minus 10x minus 4. So it's going to be what now? 12, because it's 2 times 6, it's 12x. Subtract 1 there, it's 1. Ne? Then I said, remember that it's going to be negative 10, just like that. Then you equate to 0. Oh, sorry, that's the second derivative. So for concave up, if you equate, it's just the point of inflection. So if you just use the inequalities, that's for concave up and concave down. So it's going to be 12x minus 10 bigger than 0. It's for concave up. Then 12x bigger than 10. Then x bigger than 10 over 12, which is I don't know, let me just use my mental math. Divide by 2, 5 over 6. So that is the answer. So those are the values of x for which the function will be concave up. So guys, thank you for watching this video. The next question will follow. Please do not forget to like and subscribe.